Okay, so now we are going to look at the nature of roots. The nature of roots. What are roots? Roots are the x values when an equation equals 0, or the unknown values. The equation could be x values, it could be k, it could be any unknowns, but usually in math we have the format y is equal to ax squared plus bx plus c. So these x values, that's for quadratics, right? For a quadratic, even if it is y equals b over x plus 1. So this x, if it was, various equations, I'm just trying to show you the x value, the unknown value. If that equation is y equals minus 3x plus 1, the x values. So the x values are the unknowns, okay? The x values are the unknowns. All right. So for equation, the x values when the equation equals 0, those are the roots. Also, these are the x-intercepts of the graph. Okay? The x-intercepts of the graph. So x-intercept or y-intercept means, for y-intercept, it means where the graph touches the y-axis. X-intercept means where the graph touches the x-axis. For example, if this was our y-axis and x-axis, and a curve came like that, right? You can see that this curve touches the y-axis, so it has a y-intercept, does not have an x-intercept, okay? But if the graph came maybe like that, then we could see it has an x-intercept. So when we say the x-intercepts of the graph, those are the roots we're talking about, okay? The x-intercepts, not the y-intercepts, yeah? Okay. So, in determining nature of roots, it does not mean we need to solve the equation. We do not solve the equation when we are determining nature of the roots. We do not solve the equation when we are determining nature of the roots. Okay? So we have to use the discriminant to define the nature, to determine the nature of the roots. We do not have to solve for x and y. We do not have to solve the quadratic or the simultaneous equations. We do not have to do anything of the sort. We just have to use the discriminant to find the nature of the root. Okay? So when the discriminant that tells us the nature, where do we get this from? Where do we get this formula from? This is our key in determining the nature of the roots. But where does this come from? This comes from the quadratic formula here. The quadratic formula, if you recall, the x minus b plus minus root, square root of b squared minus 4ac all over 2a. Okay? So if we have an equation, 2x squared plus 3x minus 4 equals 0, What is our A? This is our A is 2, our B is 3, and our C is minus 4. Okay? So if we wanted to find the nature of the roots, we would just get 3, okay, squared minus 4 times A, which is 2, times C, which is minus 4. Okay, so we just feed in the values from the equation. Okay, someone will say, what if I have an equation that doesn't look like that? Okay, so how about we have this equation, 4x squared plus 8 equals 0. Oh, someone will say, well, we don't have all the roots. How are we going to, we don't have the values. How are we going to do it? No. You do have the values. Look closely. You have your A as 4 because that's the coefficient of x squared. Where is the B? The B is 0 because the coefficient of x times 0 gives us 0. That's why x does not exist. So we would take our B as 0. Okay? So it would be our 4 is A and our C is 8. So it would be minus 4AC. Okay? B squared is 0. Can you see that? Okay. Okay, so we have either you have no real roots or you have 2 equal real and rational roots, or you can have two real rational roots that are not equal, or you can have 2 real irrational roots. Either of these solutions as nature of our roots. So let's go deeper and look at the nature. How do we see from the discriminant? How do we decide that there are no roots? There are no real roots. How do we decide that there are 2 equal real and rational roots? How do we get this? Okay. Okay. So now, if we see our discriminant, if b squared minus 4ac, if b squared minus 4ac is less than 0, that means it's negative, right? Because any number less than 0 must be negative, okay? So it could be negative 1, it could be negative 2, negative 10, negative 2.5, whatever it is, but a negative number, right? That would mean that in the quadratic formula, we would find the root of a negative number. Remember, the root of b squared minus 4ac, right? Keep that formula in mind, guys. Keep that formula in mind. X is equal to minus b plus minus root of b squared minus 4ac over 2a. Keep it in mind. So when you look at that formula, why do you think that it tells us the roots are not real? It's because if it was a negative number, how do we get the root of a negative number? It's impossible. It doesn't exist. That's why a graph with the discriminant with this equal to, less than 0, the roots are not real. There are no x-intercepts. The graph cannot cross the x line. It cannot, okay? It cannot. So that's why this nature of the roots of such a graph is that the roots are non-real and there's no x-intercept because the value is less than 0, right? That's one of the nature of the roots, okay? The other one is when this equals to 0, no more less than, but now equal to 0. So b squared minus 4ac, b squared minus 4ac equals 0. What would that imply here? It means this would be 0 because root of 0 has to be 0. So the answer for x would be minus b over 2a, right? That's why you see here that roots are real and equal, and there's only one x-intercept, and that's at the turning point. So we'd have only one root. That's why you see the answer here. If this is 0, then we just have the minus b over 2a. That's why the intercept will be at the turning point. If it only crosses the x line at one point, then it can only be at the turning point, either here going up that way or going down that way, okay? So for b squared minus 4ac equal to 0, roots are real. Yes, they exist, but it's only one, and of course it crosses the x-intercept at the turning point, okay? It could be here, it could be here, wherever it is, but it's only one, and it crosses at the turning point. Okay, so we can also have where our b squared minus 4ac is greater than 0. And what does that mean? That it is a positive number, okay? So this would be a positive number. So that means you can find the square root, okay? You can find the square root, okay? Yeah, so if we have our b squared minus 4ac as positive, and the roots are real, roots are unequal, meaning there are two unequal roots, okay? So apart from that, the roots are real, the roots are unequal. Now we want to distinguish if they are real and unequal. Are they rational or irrational? What determines them being rational or irrational? So if it's a perfect square, like a number that has a square root, a perfect, a rational square root, right? Like 9, like 16, like 25, like 4, okay? These numbers have square roots, okay? So 25 square root, you say 5 squared, you get 25. It's a perfect square. 3 squared, so if the number was 9. 4 squared, if the number was 16, okay? 8 squared, if the number was 64, you see? So these perfect squares, rational numbers, okay? So here, if our b squared minus 4ac was 25, we know 25, it's 5 squared, so the roots are also rational. On top of being real and unequal, they are rational, okay? Then, if it's not a perfect square, maybe b squared minus 4ac is 7, okay? That would mean root of 7 in the formula. Root of 7 is not a rational number. It would just be something point something, okay? Use your calculators and see. Then the roots are irrational, okay? Nevertheless, rational or irrational, as long as this is positive, then we have the situation here. We have real roots that are unequal, okay? Real roots, but they are not equal, okay? So, thank you.